Okay, people. So, a little less than half, or a little over half a minute left to complete the warm up. I see some of you are just now joining. Again, I want to emphasize that all of our assignments will be due next Tuesday, a week from today. And so, if you're not able to get to them in our class time, then you still have a week to do them. So don't worry about if you haven't done the warm up. Just as long as it's done by next Tuesday before class, then you are good to go.
I'm sorry, can you say that again? I was talking to my mom.
Yes. So I'm going to make all of, hold on. Oops. I'm going to make all of our assignments due on September 1st, which is a week from today. That way, and that's also the end of our unit. That way, if you miss a day or if you don't have enough time during the class period to get something done, I'm not going to penalize you for that. You know, of course, we are in very challenging circumstances. So as long as you get it done by September 1st, which is the end of our units, the last day of our unit, then you will not be penalized in the grade book for that. So if you didn't have a chance to do the warm up today, just kind of keep a mental note or maybe write it down in your planner or whatever else you use to stay organized and remind yourself, hey, didn't do unit 1, day 2's warm up. Make sure I go back and do that before next Tuesday. All right, so
Thank you.
You're welcome. So what I'd like to have somebody volunteer to read either both the objective and the essential question or one of them, whichever you choose. Anybody, please.
Biologists would be able to contrast between the energy produced compounds by completing a reflection activity.
Excellent. Thank you so much, Kiki. And can someone do the essential question for us, please? Okay.
Differentiate between the function of carbohydrates and lipids.
Thank you so much, Adrian. So yeah, today we are talking about the difference between carbs and lipids. And we do focus on these two for a specific reason because there are some similarities between the two. And let me make sure I refresh this because I did add a slide. But we are going to investigate into further detail what these two polymers, what these two organic molecules are. And you all will have an opportunity at the end of the class to complete a very short activity, should take maybe 10 minutes, that requires you to compare and contrast the two. So let me go back to where we are. Okay. Just as a reminder, yesterday we did have a couple of different assignments. So I will share my Canvas page with you all. Yesterday on day 1, we did have the Amoeba Sisters Biomolecules video, and it was just it's about a 10-minute video that also has some associated questions with it. So as you watch the video, you can answer the questions. And then also from day 1, we had the biomolecules practice. I actually intended for that to be on day 2, so that was my fault. So if you didn't get to it yet, that of course is not a big deal. And as I said at the beginning of class, all of these assignments will be due on September 1st. But go ahead and make sure that you knock both of those out just to stay on pace with the class. You don't want to fall too far behind, because if you get to Monday and you haven't done the majority of the work, it's going to be a stressful time for you. So just avoid that. Stay organized. If you need help with organization, please let me know, and we can try to incorporate that into one of our upcoming lessons. But this stuff really should be done in the 35 minutes that you all have for our asynchronous portion of class. And then the exit tickets as well. Another thing I want to point out, I did upload the live recording from yesterday as well. And so that's something that I'm trying to do every day by about 3 o'clock. You should see the live recording from the class there. That way, if you weren't able to log into the live portion of class and you missed the presentation and you still want to take notes, you can just go in and look at the live recording. And I'm dating them all as well. So unit 1, day 1, and then also August 24th. So you'll see today's recording, like I said, no later than 3 p.m. Okay, I'll go back to the slides. Okay. So we talked yesterday, we introduced these 4 organic compounds. Can someone just remind me what the 4 organic compounds are? Hopefully you have your notes out.
Carbs,
Excellent.
lipids,
Excellent.
protein,
Proteins, yes. And one more.
Nucleic acid.
Nucleic acids. Thank you so much, Alicia and Ayana tag teaming there. And also I want to shout out Ayana and Kiki for having their cameras on. That's beautiful. I really am learning. Of course, guys, I'm not going to force you to have your camera on, but it does help me to be able to see your faces and know, like, okay, they're a little bit confused on that part, or I can see you nodding and saying, I got it. That's just helpful to me because, of course, if we were in class in person, I'd be able to tell by your body language if you were understanding something. But in this virtual setting, that's very difficult to do. And thank you, Gabrielle. I see you just turned yours on as well. But we did talk yesterday about these 4 organic compounds. We just were reminded of what those 4 are, and we're going to talk about 2 in detail today. But all of the organic compounds have specific things in common. If you remember from yesterday, they all have 3 elements: carbon, hydrogen, and oxygen. But even more than that, we call them organic because they all have CH bonds. They have bonds between the hydrogen and between the carbon. All right, so that's extremely, extremely important. And there's actually an entire field of chemistry that's dedicated to this concept. It's called organic chemistry, and it's the hardest class that I've ever taken. So if any of you are thinking about pursuing careers in medicine, which hopefully some of you are, be on the lookout for that class because it is, as the kids say, ham. But I won't talk about that too much. This organic concept just means that there are bonds between the carbon element and the hydrogen element. Then we have other compounds that are what we call inorganic, and that just means that they are lacking those carbon-hydrogen bonds. Water, for example, is inorganic. Of course, there's no carbon in water. Water is H2O, 2 hydrogens, 1 oxygen, no carbon. So that means it's inorganic. Salt, the table salt that many of you use in your food, to season your food, is NaCl. Na is sodium. Any ideas as to what Cl is? It's the same stuff that people put in pools.
chlorine,
Chlorine, yeah. So NaCl is sodium chloride. And of course, there's neither carbon nor hydrogen in that compound, so it's inorganic. Carbon dioxide has carbon, but no hydrogen. Any thoughts as to why we call it, and if you can look at this picture to get a hint, why do we call it carbon dioxide? This picture should be a big hint to you. I'm gonna wait about 5 more seconds and see if folks know, if people have a guess.
oxygen,
And yeah, so we have oxygen, so that's where the oxide part, but what about di? Where's the di portion of the word coming from?
Because it's in the middle.
Okay, that's a good guess, but, and I that is actually a really good guess, but that's not exactly why. I think that was Castro who said because it's in the middle, or maybe it was, I'm not sure who it was, but. Okay, di, the prefix di means 2. So if you see in this picture, we have 2 oxygens. So that's where we get dioxide from, 2 oxygens. All right, and that's chemistry. Most of you will be taking that next year, so you'll get a lot of that, the naming rules. But that's the main difference between organic and inorganic. Organic has to have carbon-hydrogen bonds. Inorganic is lacking those bonds. Questions about that?
No.
Thank you, Adrian. And I also see you shaking your head, Ayana and Gabriella. Thank you. Okay. All right, so just as a quick review, and if you feel like you need to write this down because it didn't fully sink in yesterday, I absolutely encourage you to do that, or type. I know some of you are taking notes on your laptop and on your phone, whatever works for you. Quick review, mono as a prefix just means one or singular, and poly as a prefix means many or plural. So this image on the left side of your screen is a good depiction of the difference between monomers and polymers. A monomer makes up a polymer. So here I've got a red monomer, I've got a blue monomer, I've got a yellow monomer. And so these monomers are singular. But when I join them together, I create a polymer. So that's why you'll hear us refer to monomers as the building blocks. They're the individual building blocks. And as I begin to combine them and I build up a larger structure, that larger structure is called the polymer. So here in the middle, I've got a polymer of 3 monomers. And down here, I have a polymer of 5 monomers. The 4 organic compounds that Ayana and Alicia told us at the beginning of class, carbs, lipids, proteins, and nucleic acids, they are each considered polymers. And therefore, they are each made up of their own monomer. Okay, and we're going to talk more about that for 2 of the polymers today, 2 of the organic compounds today. But I really need you all to fully understand the difference between monomer and polymer. And if you're like, okay, Mr. Rudd, we get it, it's easy, then I apologize. But if you are confused, please don't hesitate to ask any questions. And you can just come off of mute because I'm trying to switch back and forth between the slides and seeing your faces as often as possible, but I'm not able to do it constantly. So if you have a question, just take yourself off mute and just interrupt me, that's fine. Okay, does anybody need more time to look at anything here?
No.
Okay, thank you. All right, so you all in my honors class, I want to push you a little bit further. I want you to really put your thinking caps on. I see Jalen has his on already. But we really need to kind of think through some of these concepts a little bit further, a little bit more in depth. And you all are 100% capable of doing that as my honors students. So here's a question I have for you. If all types of protein are made up of the same monomer, how do we end up with so many different types of protein? For example, I've got hormones, which are a protein, but I've also got antibodies, which are a protein. I've also got the keratin that's in my hair and in my fingernails, that's a protein. I've got the melanin that's in my skin, that's a protein. These are all different types of proteins, and they're made up of the same monomer. So what makes them different?
Is it DNA?
Ah, that is a big reason. Who said that? Alicia. That is a big reason why, and that's 100% correct. That is a big reason why they are different. That's one of the reasons. And it's the amounts of monomers that they're made out of. So some of them might be made out of 300 monomers. Some of them might be made out of 3,000 monomers. So the number of monomers that we're using is important. Any other thoughts? Think about, continue to use this analogy of Legos for monomers and polymers. Hopefully you all have had some experience with Legos, but if not, I apologize for using this analogy. But Legos are those building block toys. So just like Alicia said, I can have, I can create one specific shape. If I have 50 Legos, maybe I can make a barn. But with 5,000 Legos, I can make a castle. But also, you also, if you have any experience with Legos, you know that not all Legos are the same shape. Some Legos are more rectangular. Some of them are cubical. Some of them are, they're shaped like cones, they're conical. So that shape is also extremely important in determining what the function of the protein is. And this is a huge concept in science. And it doesn't matter if you're talking about biology, chemistry, physics, all fields of science focus on this. And I'm going to send it to the chat. Shape determines function. Shape determines function. Please write that down because it's going to come up in a number of different ways in our class this semester. Shape determines function. If I change the shape, and I change the function. Okay, so that diversity of both size, aka number, how many monomers I'm using, and also the diversity of shape, the orientation of the monomers that I'm using, is what gives me a diversity of function. That's how I can come up with all these different proteins. And the same thing goes for the other organic compounds as well. So for proteins specifically, and we're going to talk more about this tomorrow, there are 20 different types of amino acids. So that gives me millions of potential combinations to come up with all these different proteins. And they have different qualities as well. And if you end up really being interested in biology, you can take the AP biology class in which we talk about each of these amino acids more specifically and some of their properties, but we won't do that in this class. But each protein has a specific shape that is just a little bit different, right? You can see that each of these is just maybe just slightly different than the other one. But those slight differences end up having pretty profound impacts on the ultimate function of the protein. Okay, so I'm glad we're thinking in the right way through that. Thank you, Alicia, for that wonderful contribution. Any questions on that subject?
No, sir.
Thank you so much. But just continue to think through these monomers and polymers in terms of Legos. If you know what Legos are, if you've played with Legos, they are the perfect analogy for thinking through monomers and polymers. Okay, but specifically today we're thinking about carbohydrates. We've got about 14 minutes left in our synchronous portion of class, and that should be plenty of time. But you should be taking notes on this portion, hopefully. Hopefully you're writing or typing. All right, so carbs, and this is going to be one of the biggest difference between carbs and lipids. Carbs provide quick energy. 24 hours, you should be able to burn these carbs and convert it for energy. And they also contribute to the structure of the cell. The monomer, also known as the subunit, also known as the building block, the monomer of carbohydrates is called a monosaccharide. Monosaccharide.
Mr. Rudd,
Yes, sir.
if carbohydrates provide quick energy, does protein provide slow energy?
Okay, I love the way you're thinking, because we do have something that provides that long energy, the slower energy, but it's not proteins. Perhaps we have another guess as to what it is.
Is it lipids? Lipid?
It's lipids, yeah. All right, so we call monomers, we call them subunits, we call them building blocks, but we're talking about the same thing, monomers. And so this specific monomer is monosaccharide. Any guesses as to what that means? We should know what mono means. What about saccharide? Mono means one. And saccharide means sugar. So in the chat, I just sent some information you might want to write down as well. But mono means one, saccharide means sugar. So I combine the two, monosaccharide, that means one sugar, one sugar. There's some information here that I should have included in the slide, but that's not here. And then please make sure you're checking the chat. I'm sorry that I didn't include this information in the slides, but monosaccharide is also known as glucose. Glucose. All right, so glucose is the monosaccharide that we're talking about. And we're going to talk much more in depth about what glucose is, but that's the monosaccharide. Any questions up to this point? I see folks shaking their head. Thank you so much. All right. So these carbs provide us with quick energy. What happens to the carbs if I don't, if I take in a whole bunch of carbs, I'm eating nothing but bread and rice and candy, I'm taking in a lot of carbs, but then I just kind of sit around all day and I don't use those carbs. What happens to them?
Do they turn into fat?
They do. They are converted into fat, and our body wants to store it so that we can use it at a future point. And in some cases, in extreme cases, they can get clogged in our blood vessels, which can lead to very damaging effects. So if you're taking in a lot of carbs, then you should also be using a lot of carbs. Otherwise, the best way to lose weight is just to decrease the amount of carbs you're eating. Okay. So of course we talked about this yesterday, but please also make sure that you copy down that general picture of a carbohydrate. So this is a general picture of the polymer carbohydrate. We've just got, and there is a reason why the shape is a hexagon, so 6 sides. That's done on purpose. So make sure that you're trying to copy this down as closely as possible. It's just, it's like a chain link fence. We've got a whole bunch of hexagons linked together. And just as a recap, yesterday I talked about that 1 to 2 to 1 ratio, meaning that if I have 1 carbon, I have 2 hydrogens and 1 oxygen. So if I have 5 carbons, how many hydrogens should I have?
10.
10. Excellent. And how many oxygens should I have?
5.
Excellent. 5, right? And so that's how we maintain that 1 to 2 to 1 ratio. I will always have twice the number of hydrogen atoms as carbon atoms. And I will always have the same number of oxygen atoms as carbon atoms. Okay. So just a bit more information. Monosaccharide means 1 sugar, and polysaccharide means many sugars. If I have 1 sugar, it's monosaccharide, and that's called glucose. Just as an example, this is not necessarily something that you need to write down, but if I have 2 sugars, it's called disaccharide, and that's called sucrose. And then many sugars put together, in this case, I have 1, 2, 3, 4. That's considered a polysaccharide because there are many sugars. And when I have 4 of them, that's called amylose. Now, what do you notice about the words glucose, sucrose, and amylose? What's similar about them?
They have an O.
They all end in O's. Yes, so this is important as well. Sugars end in the suffix ose. But if you see ose, O-S-E, if you see O-S-E, your mind should automatically associate that with sugars. And as we talk about it more, you'll start to get in the habit of doing that. You'll find these patterns in science. And they're there for a reason. They're there because the people who created these terms wanted to make them a bit easier to remember. But as you start to pick up on these patterns, you'll notice that many of them reveal information about these words. Like I said, a lot of words that you've never seen before: disaccharide, polysaccharide, amylose. But you'll start to pick up on the patterns and break the words down. It'll make it a little bit easier. But OSE, that OSE ending represents a sugar. Okay. All right, and then also please do write down some of the common examples for carbohydrates. We've got glucose, starch, which is the most common polysaccharide in plants. And plants, of course, have to be able to stand up in some way. Most plants, trees can end up growing to be hundreds of feet tall. Even small blades of grass are not just limped over if they're healthy, right? They stand up, and starch is what allows them that ability. Starch gives them that structure and that rigidity. Our bodies have bones. We have a skeleton that allows us to support our weight and stand up. But plants, of course, do not have skeletons, but they do have starch, and that's what gives them that structure, as well as cellulose. And just as Alicia said earlier in class, the difference between these sugars is really based on the different numbers of monomers that make them up, right? So just one monomer is called glucose. If I put together two monomers, I create sucrose. If I put together four monomers, I create amylose. Glycogen is also made out of just one sugar. So it's also considered a monomer, but the difference is that it's shaped differently than glucose. So that's why their names are similar, glucose and glycogen, but they're shaped differently. They're almost mirror images of each other, but that's kind of a deeper concept. Okay. Any questions about this so far? Thank you, Ayana. All right. Glucose is the most common monosaccharide. All right, so we want to practice some test-taking strategies. So when you're taking the test, of course, our goal is mastery on all formal assessments, but also we're thinking about the EOC, right? The EOC is something that we'll take in January. So it's a long ways off, but we need to be practicing periodically to prepare you all for that. So just in general, some good test-taking strategies, whether this is for biology or English or an AP exam or the ACT, whatever it is, you want to be able to identify the key terms in the question. You want to be able to do some type of brain dump. So whether that happens on paper or if you're just doing it mentally, you want to be able to associate those key terms with some of your prior knowledge. So that's what we mean by brain dump. If I see a word in the question that I know, well, then what do I know about that word? What's all the information that I can refer to that might give me hints about what the potential answer could be? Once I've done my brain dump and I've gotten out all of that information, then I want to go back to the question, because some of the information that I've dumped is not going to be relevant to that specific question. Some of that information is just stuff that I associate, but is not useful to answering that specific question. And then I start to look at the answer choices and I make the best choice. All right, so the question we have here, which of the following correctly describes a carbohydrate? So let's just go down and look at some of these answer choices. We're thinking about a carbohydrate. So that's our key term here. In the last few slides, we've presented a whole bunch of information about carbohydrates. So already in my mind, I should be thinking about something. What's something that I should brain dump? What information should I be thinking about even before I look at the answer choices here? What do I know about carbohydrates?
That it gives quick energy.
Exactly. Yeah, that's most important here. The function is quick energy. Thank you, Ayana. What else? What else can I associate with carbohydrates before I'm even looking at the answer choices? Melissa, Amari, who else is on here who I haven't heard from? Stephanie, Jalen. Just from the last few slides, guys, what have we been saying about carbs? Go ahead, Amari.
Huh?
What are we? What information can you associate with carbohydrates? What have you learned in the last few slides?
Isn't like the carbohydrates? Isn't it supposed to be like part of like the energy, like the
Okay,
stuff?
so Ayana already gave us that. We should be thinking about quick energy here. I think Gabriella was going to help you out. Did you?
I cannot hear.
They have a hexagon structure.
Okay, they do have a hexagon structure. Cool. What else do we know about carbs? Again, this part of the question, we're just dumping information out. We just want to get some, quickly, because of course on a multiple choice question, you don't have 5 minutes or a multiple choice test. Jalen, what do you have for us?
Yeah, but 1-to-1 ratio.
They have a 1-to-2-to-1 ratio. Excellent. And we know that they have carbon, hydrogen, and oxygen. Good. All right. So at this point, again, you want to be quick with this, and we'll get better with it as time goes on. But you just want to get some information out that you know. If I see the word carbohydrate, I should already be thinking, okay, sugar. I should be thinking quick energy. I should be thinking ending in OSE. I should be thinking glucose. I should be thinking 1-to-2-to-1 ratio. I'm glad Jalen said that. Okay, so now we can look at the answer choices. We're thinking about which one of them best describes a carbohydrate. So answer choice A says, a macromolecule that is made up of quick energy and cell structures and gives the body monosaccharides. What's wrong with that answer choice?
The quick energy.
Okay, so we do, as Ayana, I think, was the one who said it, we do know that carbs give us quick energy, but in this answer choice, as Castro just pointed out, they're saying that it gives us monosaccharides and it's made up of quick energy. So it's switched. In reality, macromolecules are made up of monosaccharides and they give us quick energy. All right, so in that answer choice, the key points, the key aspects of the answer choice are switched. So that can't be it. Answer choice B says a macromolecule that is made up of carbon, hydrogen, and oxygen in a 2-to-1-to-1 ratio. Jalen, can you tell us why that's wrong?
Because it's a 1-to-1 ratio. I mean, I forgot what it was. Hold on. It's a 1-to-1 ratio.
Excellent. Yeah, I know that's kind of hard to say. So it's a 1 to 2 to 1 ratio. And so they switched it here. They gave us 2 to 1 to 1. All right, so that can't be right. We can cross that one out. Answer choice C says a macromolecule that is made up of monosaccharides and gives the body quick energy as well as cell structures. What's wrong with that one? Okay, looks like either you all are still being a little shy or you've realized that that was a quick question, because there's nothing wrong with that answer choice. In fact, this is almost the exact opposite of answer choice A. And as you guys start to become good test takers, you'll notice that oftentimes on a test, when they present you with two opposite choices, often, not always, but often, one of them is going to be the answer. And then we can just look at D. On a real test, you might be short on time. So once you find the right answer, if you're confident in yourself and if you trust yourself to have identified the right answer, then you just move on. No need to look at D. But here, we'll just take a look at D, just as an exercise. It says a macromolecule that is responsible for creating long-term energy for our cells and bodies. As Adrian pointed out earlier in the class, we do have a specific type of organic compound that gives us long-term energy, and Alicia correctly identified that as being lipids, but not carbohydrates. Carbohydrates are for quick energy. All right, so C would be the correct answer here. We're going to keep coming back to these test-taking strategies, and of course, they're useful beyond biology. All right, so the other organic compound that we're talking about today is called a lipid. As Adrian and Alicia kind of tag team and collaborated for, lipids do give us that long-term energy, but they also provide insulation. And in our next unit, we're going to talk about what's considered a cell membrane, which is basically like the outer layer of the cell. Lipids create that outer layer. The monomer, aka subunit, aka building block, of a lipid is three fatty acid tails and a glycerol backbone. So we're going to see exactly what that looks like, because I know that sounds confusing, but you'll see exactly what we mean by that. But just keep that in mind: 3 fatty acid tails and a glycerol backbone. It kind of looks like the letter E, a capital letter E. We've got a straight up portion that is your backbone, and then we've got 3 tails that shoot out.
What is the word before hydrogen?
What do you think? We've got 3 atoms that make up the lipid. Hydrogen and oxygen are 2 of them. What's the other one?
Carbon.
Carbon, yeah. Okay, so lipids are important. And again, we often like to think through our human perspective, but other forms of life use these organic compounds in very diverse ways. So lipids are important for humans because, like I said, our cells need lipids to create their outer layer. But other animals and other plants use lipids for other reasons, and we're going to talk about that. Okay. So some common examples of lipids are fats like butter or olive oil, vegetable oil. There are some good fats and there are bad fats, like we talked about yesterday. And then also waxes. So candles are made of wax, and typically that wax is coming from the fat of an animal. Historically, it comes from the fat of many farm animals, like pigs. Phospholipids, that's a big word, and we'll talk more about that in our next unit. But phospholipids are a class, a type of lipids, and they, again, make up the cell membrane, which is the outer layer of the cell. And then steroids. Steroids are lipids as well. So if you ever see someone on steroids, we know that in athletics, people use steroids as a performance-enhancing drug. So the steroids are essentially a fat that allows them to build up muscle faster or to recover from injury faster. But then also some people have to be on steroids because of a specific disease that they're fighting, and it'll start to make them appear fatter. Their face will puff up a little bit, and that is because steroids are a fat. They're a type of lipid. All right. And then
I have a question.
Yes, ma'am. Go ahead.
Does certain types of medicine count as steroids as well, like prescriptions?
Yep, absolutely. Yeah. So corticosteroids are a type of prescription medicine that you might have to take. Oftentimes, people who are battling specific types of cancer have to take steroids to counter some of the side effects of their chemotherapy. And so that's why you'll see some people who are battling cancer and who have chemotherapy treatments, they start to gain weight and their face puffs up because they're taking steroids as well. And so it's just steroids are one of the many ways that science has advanced to allow us to counter some of the diseases that our bodies have to fight. But that was a good question. All right, on the right side of the screen, you'll see a polymer, so a lipid polymer, and that is this entire thing, this entire chain here. And you can see what I mean by the letter E. This time it looks like it's the letter E turned on its side, but you can see what I mean. Each one of these individually is considered a monomer. So we've got the blue glycerol backbone, and then we've got 1, 2, 3 fatty acid tails, which are purple. Now, in reality, these are all made of specific atoms and molecules as well, but that's just a bit above the level of this course. So as long as you can, in general, understand what it looks like, you should be able to fully understand and identify the lipid. It's 11:11, make a wish. Okay, I'm gonna move on. All right, so here's an example of how you can see the atoms. You see that this is just a long chain of of carbons, just a lot of C's, and each of those carbons is surrounded by hydrogens. There are some clear differences between this yellow one and the brown one. If you notice that these two carbons do not have hydrogens attached to them on the top, and that's important, but again, that's a little bit above the level of this class. So I won't go into depth about that right now. If you have questions, you can always let me know though. All right. So shortly, or just below just below your surface level of skin, your epidermis, which is the top layer of skin, many of us have deposits of fat, and most of that fat is there for a reason. It provides insulation to us. Just like whales have blubber, and that blubber keeps them warm in the very cool waters of the North Atlantic or North Pacific seas. And our skin, our bodies need some type of insulation as well. And so some amount of fat is normal, and it's actually good for your bodies. Of course, when it begins to become excessive, that can have some dangerous impacts or effects on your body. But our bodies are very, very resilient, and we can handle a lot more fluctuation than most people realize. So some amount of fat is good. A little bit more than that, like good amount, is still okay. A little bit less than that good amount is still okay. But anything that's considered excessive is when you start to get into the potentially dangerous category.
Where's the bone at?
In this case, it's hard to see, but it's right here. I don't know exactly what it looks like on your screen, but it would be right under here. And this is actually someone's, yeah, this is right above someone's ankle. So we'd be looking at, I'm trying to see if it's noted on here, but we'd be looking at calf muscles. This is called the fascia. So if you've ever heard someone say that they have, they're having fasciitis, that can be pretty painful in your ankles and in your feet. And it's because these tendons here are inflamed, they're swollen. And of course, there's also muscle, a good amount of muscle here. Okay.
I have a
Yes.
So in that image, so you see like there's like the fat around like when they cut it open. Is there like a way that they could take it out the fat from doing that?
Yeah, and you've heard, I'm sure you've heard of a procedure called liposuction, which is where the surgeon will literally, you know, there's a machine that allows them to actually suck out a good portion of the fat. And sometimes you'll also see them do what's called cauterize the fat, and so they'll just burn it. And sometimes if it is tumorous or it's cancerous, then they will have to do what's called excise the fat, so they'll cut it out. So that we do have like those three main methods of removing it. We can suck it out via liposuction, we can burn it via cauterization, or we can cut it out via excision.
What about amputation?
Yeah, I mean, amputation would involve the removal of an entire body part. So not just the fat, but also the muscle and the bone, and also any surrounding tendons. And so oftentimes, depending on the severity of, you know, whatever the reason is that the person is having to undergo an amputation, typically is because that portion of the body is not receiving blood flow anymore. When your extremities, so your fingers, your hands, your arms, your legs, your feet, when they stop receiving blood flow, that's dangerous because the tissue will start to die and can become infected. If it becomes infected, then that infection can spread to other parts of your body that are more essential, like your heart, your lungs, your brain. So when body parts start to die, oftentimes doctors and the patient will make the difficult decision to amputate that body part. And depending on the severity of, like I said, the disease or the injury, they will cut off more or less. They will amputate more or less of the body part. So sometimes people who are diabetic, as a result of their diabetes worsening, they will start to lose sensation and lose blood flow to their toes. And so if they kind of catch it early, then maybe the person will just need to have their big toe amputated. But if it becomes worse and if it's kind of neglected for a longer period of time and the diabetes gets worse, then the amputation could potentially spread all the way to the knee. Or you know, the doctors would need to remove the leg below the knee. So it just kind of depends on the severity of the injury or of the disease. Good questions. Anything else? Okay, looks like that was basically it. All right, so that's it for our synchronous portion of class today. If we go into Canvas, I didn't mean to go over the warm-up, but I'm not going to do that right now. I'm going to share this screen. I'll share this screen. If you go into Canvas, under day 2, you'll see an assignment called Carbohydrates versus Lipids. That's what we're doing during the asynchronous portion of class today. We've got about 30 minutes left. Is that correct? No, we've got about 25 or 20 minutes left. And this should take you 10 minutes if you took good notes. But I'm going to stay on this chat, of course. So if you have questions or if you missed anything, I'll be able to just go back and forth in our presentation and give you some of the hints. But once you click on this assignment here, it'll take you to this page. And once you get to this page, it has the instructions for how to complete the assignment. So you'll just click there to access it. You're going to have to make a copy of it. And of course, every time you make a copy of something, please make sure that you are doing two things: changing the name of the document so that you put your own name into it. And then also make sure that you're saving it in your biology Google folder. All right, so you're just going to click there. You're going to make a copy of the assignment, change the name, save it to your Google folder. And that will, once you click on that link, it'll take you to this assignment.
I have a question.
Yes, ma'am.
My mom called me and she wants me to do something. Is it okay if I step back? Like go see what she wants and then come back?
Yes, that's fine.
Okay, thank you.
Okay, people, so I'm going to remain here on mute, but if you have any questions or if you need to see a part of the slides that you didn't get a chance to take notes on, please let me know. You should be working on this carbohydrates versus lipids assignment. It should take you 10 minutes if you took good notes.
$10.
Mr. Rutt,
Yes, sir.
I don't see where it says file. I don't really know how to copy it.
Okay. Uh, can you see my screen now?
Yeah.
Okay. So in the top left, do you see where my mouse is?
It's not there. Hold up. It's acting a little slow for me.
Okay.
There you go. Yeah, I pulled it up. There, I see 5.
You got
Thanks.
file. Do you see, if you click on file, do you see make a copy?
Yeah.
Okay, cool.
As usual, you got to follow that.
Okay, people, it's 11:35, so hopefully you have had an opportunity to complete that assignment. Please make sure that it is shared in your biology Google folder because that's how you will submit it. So if it's shared there, then I already have access to it, and I'll be able to go ahead and input that into the grade book as soon as my grade book is complete or is completely set up. So you all are good to go. Make sure that if you weren't able to get everything done today, the due date for everything this unit will be a week from today. So just try to stay organized, try to take it day by day, and don't leave everything to Monday night. But other than that, have a great day, and I will talk to you all tomorrow.
Bye.
Bye, Kiki.
Bye.
All right, Adrian, have a good day. See you,
Bye.
Cash.
You too.
Bye.
Right.
Bye-bye. Have a good day.
Bye.
See you, Alicia. See you, Jalen.